Welcome to day 52 of our school year. Go 128 days left. Let's get down our beginning fraction. We have a total of 180 school days, so that is our denominator. Our numerator is 52. So let's get down our factors of our numerator, which is 52. Two factors we always know are 1 and the number itself. And then using the commutative property of multiplication, I can also write it as 52 times 1. Now I'm going to check for my other factors using my divisibility rules. And I want to go in order so I don't miss any. So after 1, I try 2. The rule for 2 is that it ends in an even number. 2 is an even number, so 2 is a factor. I can get 2 20s out of 50, and then I'm left with 12, so I can get 6 1s out of 12. 2 times 26, 26 times 2. Now I try 3. The rule for 3 is that we add the digits together. 5 plus 2 is 7. 7 is not a multiple of 3, so 3 is not a factor. Next I try 4. One thing you can check is if the second factor with 2 is even. It is, so 4 will be a factor. 4 times 13, 13 times 4. We try 5. The rule for 5 is that it ends in a 0 or 5. It ends in a 2, so 5 is not a factor. We try 6. The rule for 6 is that both 2 and 3 are factors. 2 is, but 3 is not, so 6 is not a factor. We try 7. 7, 14, 21, 28, 35, 42, 49, 56. 52 is not in that list, so 7 is not a factor. We try 8. 8 times 5 is 40, and then 48, 56. 52 is not in that list, so 8 is not a factor. We try 9. 9 has the same rule as 3. We get 7. 7 is not a multiple of 9, so 9 is not a factor. We try 10. 10, the rule for 10 is that it ends in a 0. It ends in a 2, so 10 is not a factor. We try 11. 11, 22, 33, 44, 55. 52 is not in that list, so 11 is not a factor. We try 12. 12, 24, 36, 48, 60. 52 is not in that list, so 12 is not a factor. And then we get to 13. So we're done. Also, when you've gone in order and your second factor is prime, like 13, 13 is prime, you are done. So let's list our factors from least to greatest. 1, 2, 4, 13, 26, 52. We have 6 factors, so that is more than 2 factors, so it must be composite. Now out of these factors, we want to find what our greatest common one is. So it has to work for both. That makes it common, and we want the largest one that works for both. So greatest common factor. Let's try our greatest factor of 52, see if that works. So you want to keep your shaded separated from your unshaded. And make sure there's 52 in each. So I have 8 here. Plus 40 would be 48. 49, 50, 51, 52. 6 plus 10, 20, 30, 40. So 46. Plus 4 is 50, plus 2 is 52. And it looks like I have 24 left over. So 52 is not our greatest common factor. So let's try 26. 20 plus 6. 24 plus 2. Okay, your groups do not have to look like mine, but you want to make sure that there are 26 in each. 8 plus 10 is 18. Plus 2 is 20. Plus 6 more is 26. 2 plus 20 is 22. Plus 4 is 26. 6 plus 20 is 26. 20 plus 6 is 26. And again, I have 24 left over, so 26 didn't work. Let's try 13. And 3, let's see, 7 and 6 is 13. 4 plus 9 is 13. And 11 plus 2 is 13. Okay, so make sure your shaded is separated from your unshaded, and make sure there's 13 in each group. 8 plus 5 is 13. And 5 plus 8 is 13. 2 plus 10 plus 1 is 13. 9 plus 4 is 13. 6 plus 7 is 13. 3 plus 10 is 13. 10 plus 3 is 13. 7 plus 6 is 13. And 4 plus 9 is 13. And I have 11 left over. So 13 didn't work. Okay, so next we want to try 4. So we want to try make our groups of 4. Keep your shaded separated from your unshaded. I'm going to use perfect squares. Those are a little easier to make. 4 is a perfect square number because I can make a 2 by 2 perfect square. Remember to keep your shaded separated from your unshaded. Make sure your lines go all the way around your groups also. Try not to let your lines go inside the squares if you can. All right, there are no left over. So we finally found our greatest common factor. It is 4. So now we want to count up our total amount of groups of 4. I have 1, 2, 3, 4, 5 in each group the way I made it. So I'm going to count by 5s. 5, 10, 15, 20, 25, 30, 31, 32, 33, 34, 35, 40, 45. And I have 5, 10, 11, 12, 13 shaded in. Now that I've done my division with my model, I'm going to do it with my algorithm. And I'm dividing the shaded area into groups of 4 and the non-shaded. So it's always going to be the same number here. But it should be 2 separate numbers because I'm dividing each one separately. So I'm going to divide 180 into groups of 4 and 52 4 quarters makes 100 cents or $1. Numbers the same, zeros a game. More on top, no need to stop. Numbers the same, zeros a game. Okay, and then I'm going to trade 20. Placeholder moves it over a place. 2 times 4 is 8. Numbers the same, zeros a game. Got to add those partial quotients together. 5 plus 0 is 5. 2 plus 2 is 4. Here I'm going to do a group of 10. That's pretty easy for me to do. 10 times 4 is 40. More on top, no need to stop. More on top, no need to stop. And then 3 times 4 is 12. Numbers the same, as zeros a game. Add 10 plus 3, I get 13. Now I need to check. Divisor times quotient plus remainder. Divisor times quotient plus remainder. Since our remainder is 0 for both of them though, and the identity property of addition says when you add 0 it stays the same, I don't need to add the 0. 4 times 5 is 20. 4 times 4 is 16, plus 2 is 18. 4 times 3 is 12. 4 times 1 is 4, plus 1 more is 5. 52, that matches our dividend up here, so that checks. 180, that matches our dividend up here, so that checks. So our numerator is definitely 13, and denominator is definitely 45. Okay, now let's go ahead and fill in our data collection page. Okay, trimester 1, week 12. Today is 10/22/19, and our fraction is 13/45. Okay, we did groups of 4, so let's look in our 4s. Last one we have down is 11/45, so 12/45. That is equivalent to 16/60, and 4/15. That's its simplest form. Okay, and then today is 13/45. There is no line below it because this is our equivalent fraction in lowest terms, or simplest form. There is an equivalent fraction in the 2's. 2 is a common factor. And then, of course, 52/180. Okay, go ahead and put your number line away. Erase your worksheet, and thank you for joining me.